number 1, x cubed minus 2x over x squared plus 3x plus 2. Okay, so the first thing, step number 1, determine if you're dealing with proper or improper fractions. Okay, I won't really call this a step because all the time you're going to be dealing with improper fractions. When you're dealing with an improper fraction, you have to do polynomial division. Okay? If you are dealing with an improper fraction, you have to deal with polynomial division. Okay? So all the time, all the questions that they'll give you, you have improper fractions. Now, how you tell if you're dealing with an improper fraction, you look at the powers for the leading coefficient. Colleagues, the leading coefficient is the number, the first number on the left. Okay, so if we go to our numerator, not the first number, the first letter. Yes, we look at here, x cubed, we have the power 3 here. We go to the denominator, the leading coefficient is x squared. Okay, you take note of the power, it is 2. So since this one in the denominator has got a lower power, so you have got an improper fraction. Okay, that's just for your general knowledge. Okay, colleagues? If the power for the denominator is less or equal to the power for the numerator, you're dealing with an improper fraction. That's just for your general knowledge. So here we're dealing with an improper fraction. So we have to do polynomial division. Okay, colleagues? So all the questions they'll give you, they'll be improper fractions. So you have to do polynomial division. Okay? So let us get to know the terms. Okay? This is the dividend, the polynomial that's being split, dividend. And this is the divisor. It's the one doing the division. Okay? So let me illustrate this here. So I'll say step 1 is to do polynomial division. Okay, because as I said, you always be dealing with improper fractions. Okay. So we do that. So the dividend is the one that goes inside this sign. Okay. So put here. So our dividend is this x cubed minus 2x. Okay, that's the one that goes inside the division sign here. Okay, so we say x cubed, and you're going to say plus. Okay, when you're putting this polynomial into the division sign, you have to make the order of the powers for the letter, you have to make a proper order so that you can divide properly. Okay, this is what I mean, colleagues. This is x cubed. We don't have an x squared here. We just go from x cubed to x to the power 1. So you're going to have to put here plus 0x squared. Why we are doing this is so that you can divide properly. If you miss this step, you are going to see you are going to fail to divide properly. Okay. So the power 3 and the power 2. Yes? Is that a question? Minus 2x to the power So notice I put them in order. Power 3, power 2, power 1. Any questions, colleagues? Any questions? So let's remember the polynomial. What we mean polynomial, colleagues, is just these expressions here. Just that there's more than one term. That's what we mean when we say polynomial. There are more than one term in the expression. So this is a term. This is a term. So it's a binomial. Okay? It's a binomial because there are two terms in that expression. Then the other one below here, there are three terms here. This one's a polynomial. I mean a trinomial because there are three terms. So you just say polynomial, trinomial, binomial, you're just saying how many letters and numbers do you have in the equation. How many letters and numbers do we have in the equation? Yes, does someone have a question? Keep your mic muted because this topic, Mr. Godfrey, and this process here, I need you to pay close attention because a lot of people hate this topic. Okay? So, are there any questions so far? We'll go slow. Okay? We're going to go slow. So, have you seen, colleagues? The dividend, which is the numerator, goes where? E. Do not put them the other way around. Then the divisor, the one which is doing the dividing, is the one that comes outside here. Okay, so the divisor is what? X squared plus 3x plus 2. Okay. So that you do not put the wrong one inside. So the divisor, which is the one at the bottom, is going to come here. Okay? That's what you need to remember. Are there any questions before we begin the polynomial division?
So I have a question on the dividend. 3x x to the power 3 plus 0x to the power 2. That one on the mid.
Yeah.
As in where we got it from.
You have to put these powers in order, okay, so that you can divide properly. So we just brought it in ourselves. Okay? We brought it in ourselves because when you look here on top, it's going from x to the power 3 to x to the power 1. So it has skipped x to the power 2. So you need to include that one which has been skipped inside here so that you can do the process smooth. Because if you miss these steps, what will happen is when you start the process, there will be a point where you cannot subtract anymore. You will be stuck. So you always need to remember this step. Is that okay, Mr. Godfrey?
Sure, sir.
Yes. So basically, the powers of x should be in descending order. Have you seen power 3, power 2, power 1? Or we even put plus 0 here also. Because as you are going to see, this is going to make the process smooth. So you also add a plus 0. Okay. So now, are there any other questions before we begin the process now of division? Okay, this is the process. Divide, multiply, subtract. Basically, colleagues, the way we do normal division is the same way we're doing it with this. Okay? It's the same way we're doing it with this. Okay? The process is still the same. Divide, multiply, subtract. So we start with step 1. Divide. What are we dividing? These are you divide the leading terms. Okay, colleagues, remember this x cubed, 0x squared, 2x, and 0. They are terms. Okay? The more terms you have, it's a polynomial. Okay? So you divide the leading terms. So for the dividend, which is the expression here, the leading term is x cubed. For the divisor, the leading term is x squared. Okay? So those are the first things you divide. So we are going to say x cubed divided by x squared. It gives you x, right? X to the power 1. Remember when you're dividing same bases, okay, you will subtract the indices. So we just subtracted this 3 minus 2. That's how we got x to the power 1. Okay. So you put this x to the power 1 here. Any questions? Before I move further. Okay, step 2, multiply. So what are we multiplying? You're going to say x times x squared. You're going to get x cubed. X times 3x, you're going to get 3x squared. So I'm just saying, if we never had this 0x squared here when we're subtracting, this 3x squared, you won't have anything to subtract it with. Okay. Then x times 2, you get positive 2. Oh, x times 2x, sorry, not positive 2, 2x. Yes, positive 2x. Yes. Any questions, colleagues? That's the multiplication. Now, step 3, subtract. So you're going to subtract. X cubed minus x cubed, 0. X cubed. Okay. Don't even need to write it. It just basically disappear. Okay. X cubed minus x cubed, 0 x cubed. So it's irrelevant. 0x squared minus 3x squared. We're going to get negative 3x squared. Okay. Put them in order. This in the x cubed should align, the x squareds align, the x's align. Then negative 2 minus 2. Okay, negative 2 minus, since there's a plus here, we can still say positive 2. Remember, negative and positive make negative. So it's negative 2 minus 2. You get negative 4. Negative 4x. Because the x is there. So negative 4x. Yes. Any questions? This is 0. You just drop it there. Plus 0. Any questions? the process again. Remember, divide, multiply, subtract. So we divide. What are we dividing? The leading coefficients. So you get this negative 3x squared. It's the leading coefficient here. The leading term, basically. Not coefficient, leading term. Here, for the divisor outside is still this x squared. Okay. So here I'll put it again here. T M S. So we're going to say negative 3x squared divided by x squared. What do you get? Negative 3. Any questions? Okay, so this negative 3 here, we're going to bring it on top here. Oh, someone raised their hand. What's your question?
Sam, I think just repeat again, starting from the top there, where you're dividing, where there's yes, how we got this 3 cubed this side plus 3x squared. The x cubed here, I didn't get it.
You're talking about here negative 3x squared divided by...
Yes. No, on top first where there's the one written in no, this is
cubed.
Oh, if it's green.
Are you talking about x cubed divided by x squared?
Yes. I'm talking about one you've written on top first, the x cubed plus 3x squared.
X cubed plus 3x. Or are you talking about here x cubed plus 3x squared here?
Yes, that part.
Yes, I was multiplying here. X times x squared. That's
Oh,
x cubed.
okay. Okay, thank you, Sam.
Okay. So the process just repeats itself. Have you seen here where we divided negative 3x squared divided by x squared? We get negative 3. So we divided. Step 2, multiply. So you're going to say negative 3 times x squared here. We're going to get negative 3x squared. Negative 3 times 3x, you get negative 9x. Negative 3 times 2, you get negative 6. That's why this is 0, we also attached it there. Okay. So we've multiplied. Any questions? Step 3, subtract. So here, this is where you have to be careful, because these signs, this is where it gets a lot of people. So for the first one, this top one here, we've got negative 3x squared minus negative 3x squared. Okay, negative and negative make positive. So negative 3x squared plus 3x squared, that is 0. Okay. That is 0. So where there's a 0, you don't need to write that 0. Just leave it blank. Just shows it has gone. Okay. Yes. negative 4 minus negative 9 x. Okay, negative 4 minus negative 9. Negative and negative make positive. Negative 4 plus 9, that is positive 5x. Okay, so here we have a positive 5x here. Then 0 minus negative 6. Negative and negative make positive. So it's like 0 plus 6. You get 6. Okay. So this is where you stop. You know why, colleagues? Because if you try to divide x, you try to divide this 5x, you try to continue with the process. And you say you try to divide 5x divided by x squared. You get a weird answer. You get 5 over x, yeah. Yeah, you get a 5 over x. The answer will be like this, 5 over x. And imagine trying to put a 5 over x here and start multiplying it there. It will give you hell. So when you stop is when the leading term, have you seen this 5x? Leading term, when its power is less than the leading term for the divisor. This, have you seen, this is to the power 2, this is to the power 1. So you know that, okay, I need to stop here. Okay? If you forget this principle, you will just notice when you're dividing 5x by x squared, then you'll say, okay, no, I think I have to stop here. Okay? Yes. Any questions? Because we're not yet done. We have just done part of the process. Okay? We have just done part of the process. Okay? Okay, so this is our remainder. Okay? If you thought you would leave remainders in grade 3, that I'll never see a remainder again, here it has come again in university. Remainder. Right? So this is the next thing we need to write here. Okay? Our original expression, okay, x cubed minus 2x over x squared plus 3x. Remember, as I said earlier on, partial fractions is like, yeah, breaking down a fraction into smaller parts. So when you say equals, then you're going to put your quotient. Your quotient is the answer that you get when you divide the dividend by the divisor. Basically, this answer on top, that is your quotient. Okay, so you get your quotient, x minus 3 plus, okay, your remainder, 5x plus 6 over, so the remainder you're going to put it over the divisor here. Okay, always remember the remainder you're going to put it over the divisor. X squared plus 3x plus 2. Okay, so our next objective is to break this one. We have to break it further. Okay? We have to break it further. Alright, colleagues. So the first before start breaking it further, any questions? So step one, you do polynomial division. Step two, you have to break up the remainder. Okay, because remember, the remainder is 5x plus 6 over x squared plus 3x. Okay. You have to break up this remainder. Now, when you reach this point, colleagues, you need this quadratic way expression here. We need to also break it up. We're going to see why we need to break it up. Okay. So we need to simplify this quadratic expression. So x squared plus. I hope you remember how to factorize quadratic equations. Do we all remember how to factorize so that I skip the... Do we all remember how to factorize? Madam is not okay factorizing. Mr. Godfrey, are we okay with it? Madam Justina, Madam Shelley, are we okay with factorizing quadratic expressions?
To my side, I'm okay.
Just in case not everyone is okay. Okay. So quadratic expressions, colleagues, just remember this: a x squared plus b. Okay. A is just the coefficient of x squared, the number in front of x squared. B is just the coefficient of x, the number in front of x. C is the constant, number without a vector. So remember, with quadratic equations, just multiply first a by c. Okay. So a is 1 because there's a 1 in front of the x squared. C is what is C here is 2. Okay. So 1 times 2, we're going to get 2. Okay. So we have to look for two factors. Like when we multiply them, they give us 2, and when we add them, they give us 2. Colleagues, what are those two factors? Madam Shelley? Or when we add them, they should give us 3. So when we multiply them, they should give us a 2, and when we add them, they give us a 3. What are these factors?
Yes, sir. You are saying when adding them, they should give us
3.
3.
Yes, and when we multiply them, they should give us 2. One and 2, madam.
2.
1 and 2. When you multiply 1 times 2,
Yes.
gives you 2, right? Basically, this product which we got, this A times C here. When you multiply 1 and 2, it will give us this product here. When you add 1 plus 2, it gives us 3. Okay, this 3 here in the middle here. Your factors have to give you the middle number and this number when you multiply A and C. Okay. So these factors are 1 and 2. Okay. So the quadratic expression can be written as this now. Since we know the factors are positive 1 and positive 2, so you just write here x plus 1 x plus 2. So this is what we need to break down again. Okay, we need to break this down. This 5x plus 6 over x plus 1 over x plus 2. We need to break it down. Okay, these other terms here, they'll come when we finally broken down 5x plus this expression. These other terms will show them later. For now, we need to focus on this expression here. We need to break it down. Okay, so how we're going to break it down? Like this. Just write it like this. Let's say 5x plus 6 over x plus 1 over x plus 2 equals, we're going to put here a over x plus 1 plus b over x plus 2. Okay. A over x plus 1 plus b over x plus 2. Okay. So we need to find the values of a and b. That's what we need to do next. Okay. So how we can find those values? Okay. First, we need to get rid of these denominators here. How do we get rid of the denominators? Just multiply like this. The 5x plus 6 over x plus 1 plus 2 multiplied with x plus 1. Let me write it in a proper way so that we are seeing everything that happens. 5x plus 6 every expression you're going to multiply it with x plus 1 times x times 2. Because we just want to get rid of these denominators here. Okay. Want us to see everything that happens so that you're not asking, where did this come from? You see where everything is coming from. So for 5x plus 6 over x plus 1 plus x plus 2, cancel these out. A over x plus 1 times x plus 1 times x plus 2, cancel the x plus 1s out. Okay. B over x plus 2 times x plus 1 times x plus 2, cancel out the x plus 2s. So your expression now remains as 5x equals A x plus 2 plus B x plus 1. Any questions? Are we okay with this part? Okay. You expand now. A times x, you're going to get A x plus A times 2, you get 2A plus, when you say B times x, you get B x. B times 1, you're going to get B. Okay. So colleagues, the next step is you need to equate coefficients. Okay? Equating coefficients. That's what happens next. Equating coefficients. So you're going to say, for the coefficients of x, if we equate the coefficients of x, okay, we look on the left hand side, the coefficient of x here is 5. So you just write this 5 here. This. So you're going to say 5 equals, when we look on our right hand side here, A is a coefficient of x, plus even this B here is a coefficient of x, 5A plus B. Okay. Next, any questions? I hope we are not lost. I hope we'll attempt this question in the exam. It's 8 marks. Okay. After equating coefficients, we're going to equate constants now. What I mean as constants, numbers without letters, okay, or numbers without x. this A, there's no x there, so we equate constants, okay? Numbers without x. Because we're going to do simultaneous equations here. You can imagine this is a very long process. This is equation 1. Number 2, equate constants. Numbers without x. Equate the constants. So if we look on the left hand side, 6 doesn't have an x here. Okay. So we're going to put here 6 equals 2a doesn't have an x. So 6 equals 2a plus b doesn't have an x, so you're going to put here as b. This is 2a plus b. Okay, colleagues, are we okay with this? Any questions? This is equation 2. Was one find a and b, okay? One find a and b. So equate coefficients, then equate the constant numbers without x, or letters without x also. So this will be, we also brought it down. Excuse me. Alright, so we now use simultaneous equations to solve this. Okay. So there's the substitution method and there's the elimination method. Now usually when I see an equation like this one, 5 equals a plus b, I can easily use the substitution method. Okay. So let's adjust equation 1. We'll use substitution method. So I'm going to say, let's start with equation 1. Dealing with equation 1, we say let's make a the subject of the formula. So to make a the subject of the formula, you're just going to take this b over this side. So you're going to say a equals 5 minus b. A equals 5 minus b, and you're going to say substitute into equation 2. Okay. Even equation 1, substitute into equation 1 or 2. Okay, but we put it into equation 2. So we substitute it into equation 2. Substitute with 5 minus b. Means a equals 5 minus b. That's b. 6 minus 2 times 5, 10. 2 times negative b, that's negative 2b. Plus b. Negative 2b plus b, you get negative b. So 6 equals 10 minus b. Okay. So, want this b to be positive. Let's take it to this side. Then this 6 goes this side. So we have positive b here. We have 10 minus 6, which equals 4. So B equals 4. Since we have the value of B, we go back to this equation here. A equals 5 minus B. You just substitute B there. Yes,
So the answer is 1.
yes, the answer is 1. Okay. I hope we are getting this in our assignments. So A equals 1. B equals 4, A equals 1. So, here colleagues, have you seen here where we broke down this thing? A equals 1, B equals 4. This 5x plus over x plus 1 over x plus 2 gives us 1 over x plus 1 plus 4 over x plus 2. Okay. So what we need to do, you see the way we wrote this answer here, you need to break this down. Okay. So it's a long answer for me to write down. My finger is tired. Okay. Just know at the end, you come back to this expression here. So it's equals x minus 3 plus 1 over x plus 1 plus 2 over x plus 2. That will be your answer. Okay.